Going further into the syllabus, now we will start with impulse. Impulse is a large force acting for a very short time. It produces a finite change of momentum in the body. It is denoted by I vector equal to F average vector cross delta t, where F average is del P vector over del T. Del T cancels out to give you del P vector. Now, conservation of linear momentum, also called CLM in short, happens when V average is 0 and delta T tends to 0. V average is finite and delta T is 0. This is 0 exactly. And there is no CLM if V average is infinite and delta T tends to 0. In this case, CLM does not hold. Let us take an example, recoil of a gun. Initially, the gun is at rest. There is no force acting on the gun. Because of this expression, F average is 0. Del P becomes 0. Therefore, we have del P equal to 0. Now, del P is P final minus P initial is equal to 0. P initial is 0. Initially, the gun is at rest. Now, P final, that will give me mv plus m small v equal to 0. So big M is mass of the gun. Big V is velocity of the gun. Small m is the mass of the bullet and big V is the velocity of the bullet. Now, taking this expression on the other side, it becomes minus mv vector. So capital V is minus m by capital M V. This is capital N by V. The velocity of the gun is opposite to that of the bullet because of this minus sign. Because of this minus sign, velocity of the gun is opposite to that of the bullet. Now, if I now see the mass of the gun is very much greater than m. So if I take the mass down here, m by m is less than 1. So if you see now, the velocity, the modulus of the velocity is less than the modulus of the velocity of the bullet. The velocity of the gun is less than that of the bullet. So the velocity that what I've written here. So the velocity of the gun is very less than that of the bullet. Now let's go to another question. Suppose there is a bomb of mass 1 kg. It is kept here. It explodes. It explodes. It explodes. In the ratio of 1:1:3, two equal masses fly at right angle to each other with a velocity of 30 meters per second. What is the velocity of the bigger mass? Now let us find the masses. Now it is given as 1:1:3. So m1 will be 1 by, you take the ratio 3 plus 1, 4, 4 plus 1, 5. 1 upon 5 into 1 kg, that is 0.2 kg. 1 upon 5 into 1 kg, that is 0.2 kg. And then m3 is 3 by 5 into 1 kg is 0.6 kg. Now the mass m1 is going with the velocity v1, the mass m2 is going with the velocity v2, and they are going at right angle as per the question. Now the magnitude of the velocity are same, that is both 30 meter per second. They have given it 30 meter per second. Now using CLM, initially the bomb was at rest. So you have delta P, there was no force on the bomb, therefore delta P is 0 and delta P is 0. So now you have this. Wait a minute. This expression should have been written later on. Wait a minute. Now as delta P is 0, P final minus P initial is 0. As the bomb was initially at rest, so P initial is 0. From equation 1, P final is 0. Now delta P is 0 as delta P is 0 as there is no external force. So this expression has been properly written down here. Why delta P is 0? The reason has been written out here. Now you have to see PF is 0. So PF is M1 V1 vector plus M2 V2 vector plus M3 V3 vector. Now we just saw this is 0.2 0.02 kg, and this is 30 meter per second I cap, because V1 is going in this direction and V2 is going in this perpendicular direction. This is the x-axis, this is the y-axis. So 0.02 kg into 30 meter into 30 meter per second plus M3 is your 0.06 kg, 0.06 kg V3, and this is equal to 0. Now from here we can cancel the points and the kgs. So this becomes 60. This becomes 60 meter per second I cap, plus this becomes 60 meter per second j cap. J cap, I forgot to write it here. J cap plus 6 kg V3. Kg is also cancelled. Sorry. Kg is also cancelled. This is V3 equal to 0. Now divide the whole equation by 6. You will get 10 meter per second I cap, 10 meter per second j cap, and V3. Now let me take some more page. Now transfer this part on the other side. So V3 is minus of 10 meter per second I plus 10 meter per second j. Now the resultant velocity is opposite to the resultant of this two the resultant velocity of these two. Now what is the resultant velocity of these two? Let us find it out. Let us consider this as, let this be equal to minus v. Let us consider this as v, where v is 10 meter per second I plus 10 meter per second j. Now what is the modulus? Just a minute. What is the modulus? The velocity. This is under root of, now you can see this is the v1 vector, this is your v2 vector. You have drawn this line, this is the resultant theta, this is actually v2 which was going in this. I shifted it parallelly using parallel law of vector addition. You'll find the resultant. This is that v. The v mod is, I already told you in the lesson of vectors, this is 10 square plus 10 square, that is nothing but 10 under root 2 meter per second. Now let me take some more page here. Now this is this. Now what is the angle it is making with the x-axis? Let me see. Now this, I want to find this tan theta. Tan theta is v2 by v1 perpendicular by base 10 upon 10, that is nothing but 1. That means theta, wait a minute, let me write it properly. This is theta is equal to 45 degree. That means V is, that is first observation C, that means V is equal to 10 under root 2 meter per second cos 45 I cap plus 10 under root 2 meter per second cos 45 j cap, because this is 45, this is 45. This is the actual V. That means V is coming out to be the same as the above expression. It will be 10 meter per second I cap, because 10 meter per second I cap. This is the reverse j cap. This is the reverse check, because cos 45 is equal to 1 by under root of 2. This is the story. Now, that means That means V3 is minus V vector. That means V3 has a magnitude equal to V, that is that is 10 under root 2 meter per second, that is 1 for 10 into 1.414 meter per second, that is 14.14 meter per second. Now, just a minute, let me take some page. Yes, now if you see the picture, you will understand. This was V1, this was V2, this was the resultant V. V3 went in this direction, V3 went in this direction, just the opposite to this. This is the, with this much, V3 had a value with this. Now, it went, so the third mass, uh, went opposite to the, went opposite to the resultant of V1 vector and V2 vector. Having With this, we conclude this problem. I hope you have understood this problem.